Okay, so we're going to talk about, let's turn off your noises because you can hear me. Okay, we're going to talk about the nth root and rational exponents. So this is something that you should be doing this week. All right, I don't have my pen again. All right, so this is to kind of help you. If n is odd, so that means that if this number, hold on, let me get my little pointer. If this number down here is an odd number, meaning 3, 5, 7, you guys know what odd numbers are, then the number and then a has one real root, okay? Now, the difference between that, like if it's a 3, 125, so that's going to be 125 to the 1/3. Basically here what I want you to notice is if it's raised to the 1/3 power, then you're looking at the cubed root, okay? And then that's just 5. 5 times 5 times 5. So if n is even, excuse me, a has to be greater than 0, and then what you have is both a positive and negative, okay? So the fourth root of 81, again, look and see that they've written it. This is the fourth root. This is also the fourth root, okay? And that means it's plus or minus 3, because 3 times 3 times 3 times 3 is 81. And also if you do the negative, negative times negative is a positive, times a negative is a negative, times another negative is another positive. And if a is equal to 0, then you just have one root. And there is a square root of 0. It is 0. And if a is a negative number, I think we've talked about this, then what you have is an imaginary number, right? Like the square root of -1 is I, correct? So that's your imaginary number. Okay, so this, what you see here, this part right here is called a rational exponent because our exponent is a fraction. And if we wanted to write that as a radical, it would be the cubed root of 24. Okay, the fourth root of 28, how would that look? Oh, Sam, I am so sorry, I just saw that. How far back did you want me to go? The last part of the last slide. Oh, okay, hold on. There we go. Let me know when you're ready. Okay. All right. So again, remember that this is called the rational exponent notation. To go on to the next one is the radical notation. So that little like check mark house thing, I don't know, whatever you want to call it, that is called the radical. All right, so that would be the fourth root of 28. All right, so now we're going to look at how to evaluate these things. And if you've already done this part, excellent. If you haven't, this will help you. So if I were to rewrite this, can you guys tell me what this would look like? Can you tell me in words, not with a picture? What would this look like? What does the 2 on the bottom mean? Good, it means the square root. So what you would do is we're going to take the square root of 9 and then we're going to, by how many times? Multiply it by how many times? 3 times, exactly, perfect. So to write it in radical form, you can't see this is a 3 up here. So it's the square root of 9 and then cubed, or you multiply it 3 times. So it's 3 times 3 times 3, and that is 27. All right? Well, what about this one? First off, what does the negative sign mean? Oh no, we just talked about this. What does that negative sign mean? Means you make it into a fraction, right? It's 1 over that. Okay, so there you go. That's the first thing that you do. Now, what does the 5 mean? The fifth root of 32. Good. And then we're going to square it. That 2 means to square it. So what is the fifth root of 32? Anybody got that off the top of their head? It's 2. And then when you square 2, you get 4. So your answer is 1/4. All right? Some of these things, after you've done them like 100 times, you just remember. All right, so let's talk about solving equations. So x to the 4th is equal to 81. How would I solve that? How would I make it so that I could find x? No, there's nothing to subtract.
81 over
I think, is that what you meant?
Yeah.
Yep. I'm going to take the 4th root of both sides. So 81 to the 1 over 4 is good. And remember, since that's even up here, we're going to do plus or minus. And so what do I multiply together 4 times to get 81? 3. Plus or minus 3. Again, once you've done this 100 times, it's pretty easy. Oops, where am I? Okay. All right, let's do another one. Okay, now I have 2x to the 5th is equal to 64. What do I do first? No worries, Jenna. Divide both sides by 2, right? Because I want to get that x all by itself. So we divide it by 2. 64 divided by 2 is 35. Now what do I do? Look at the other side to help you to decide. Okay, not the square root, Jenna, but the, yeah. It's going to be the 5th root, right? Just like you did at the beginning on the other side. And since it's an odd number, there's only going to be one answer, and the answer is 2. You multiply 2 together 5 times to get 32. All right, easy enough. So, for the first one, if we want to evaluate this, that just means to find the answer, correct? So we're going to take the 4th root of 625, and then we're going to take the opposite of it. Now, if we look over here, if that negative sign is under the radical, then you're going to have some imaginary number. Does that make sense? Okay. All right, so everyone understand what I just said, hopefully. All right, so now we're going to look at properties of rational exponents. And again, this is kind of what you were working on today. Okay, so not 6.1. But, okay, so if I have the same bases, what I do with the exponent is add them. If I have a base raised to a power and then the whole thing is raised to another power, I multiply them. If I have something in parentheses and all of that is raised to a power, I take that power and apply it to each part of what's in the parentheses, okay? If we have that negative sign in front of, excuse me, the exponent, I make it into a fraction. If I have a fraction and I have the same bases, if you can see here, it's a and a, I'm going to subtract my exponents. Excuse me. And if I have something that's being divided, raised to a power, I just distribute that power to both pieces of the fraction. All right? Those are pretty important to remember. If you don't have them written down anywhere, it would be probably smart to write them down. All right. So we don't want any decimals. So what would I do with this first problem? Holy cow, we just keep going. Okay, what should I do with this first problem? I have the same bases, different exponents. What do I do with the exponents? Add, subtract, multiply, or divide? We're going to add them. And in order to add them, you have to have the same denominator. But yeah, we're going to add the exponents. That's good. All right, let me see if that one. Okay. So you've got to make this common denominator, and so we get 6 to the 5/6. What about down here? For part B, they're not being divided, they're being multiplied. Multiply them, then add. Oh, I see what you're saying. We're going to multiply the exponents. Yep. But then can I add them? We're going to distribute this 2, just making sure. Distribute this 2, right? This is just showing you in bits and pieces. Now, I took the cubed root of 27, right? That's what this means. Everyone agree? And the cubed root is 3. And then over here, we have 6 to the 1/4 times 2, right? So I just multiply those together. So now we have 9 times 6 to the 1/2. Does that make sense to everybody? This one's a little bit harder. Okay, let's do part C. Ready? Maybe not. There we go. So it's like the other one, like on part number B, but we have a negative. So you can separate them and then distribute that negative to each part on the inside. Make sense so far? Okay. Then you multiply the exponents. So 3 times negative 1/2 is negative 1, right? And then again here, 3 times negative 1/2 is negative 1. So we have 4 to the negative 1 times 2 to the negative 1. What does that negative 1 mean? What do I do with these numbers? It's a negative, so what do you do with it? Put it in fraction form. So it's going to be 1/4 times 1/2. Yes, exactly, Jenna. And then you just multiply, right? Multiply fractions straight across. So it's going to be 1/8. Last one, we have a fraction and then it's raised to a power. So the first thing I'm going to look at is, I'm going to wait till Jenna, keep typing Jenna, maybe you know, we're going to multiply the exponents. We could do this one of 2 ways. We could multiply these, or I could look at these. Can I subtract these? Let me know. Can I subtract these 2 exponents? Why not, Brittany? That's true, but why not? That is good. Because they're not. Yeah, excellent, because they're not the same base. Good. So let's multiply them. I think that's what I did. Yes, I did. Okay. And that's about as far as I can get. Maybe can I simplify 18 divided by 9? Yeah. To what? 2 and 8 and 9. 2 and 2. 2 and 2. Oh, yeah. Okay. All right. There you go. All right. Okay. What the heck? So now we're going to simplify, and then we're going to write the expression in the simplest form. So how do I simplify this one? Anybody? Anybody? Get a prime factor? You could, but it's the cubed root, right? Since they have the same root, you can multiply them together. All right? Make sense? I thought we went over this. If we didn't, okay, sorry. All right, again, we have the same roots here. So what we can do, okay, that's 5. All right, there we go. So what we can do here is we can take the cubed root of everything, divide 32 by 4, and we get 8. So what's the cubed root of 8? What do I multiply 8? Or some, what'd you say? What'd you say? 2. Excellent. All right. Yes. If the problem is in radical form to begin with, the answer should be left in radical form. Does that make sense? Don't try and change them. However they're given to you is how you should leave them. Exactly. All right, so let's do this. We're going to write some stuff in simplest form. The fourth root of, again, what you can do this one of two ways. The way that I think I would do it is I would do a factor tree for 64, but you can do it any way you want. All right. So the fourth root of 16 is 2, right? So I would have 4 2's under there, and I would look for groups of 2, and then I have the fourth root of 4. Okay. Does that make sense? Factor trees seem to be a lot easier. At least it's easier for me to see groups of numbers. All right, next one. Let's see what we get. So we're going to take each one separate. So you can't have a radical in the bottom part. And I think we did this a couple quarters ago. Okay, so what you would do is, well, don't worry about this one. Now that I think about it, I don't think we did simplifying like this, did we? Anybody remember? I don't think we did. Do you guys remember? You don't think we did? I don't think we did. No, okay. So let's not worry about that one. Okay. So we're going to perform the indicated operations. Oh my gosh. All right. So the first one. If you have the same bases, all right, guys. I don't remember how to change this. Okay. All right. Same bases. All you do is you subtract the coefficients. There we go. Sorry, I had a brain cramp. So 5 minus 3 is 2. All right, next one. We have the cubed root of 81 minus the cubed root of 3. Oops. Here we go. I don't know. This is not part of this. This PowerPoint is an old one that I just pulled that I had. So maybe we didn't do this. Do you guys remember, did we do this? I should look. Anybody? Do you remember? Do you guys? It's not in this section, is it? Okay. I don't think we did it. And if we did, do it, I think it would just be, Jenna, something that you would have been doing, or if anybody else is doing that extra folder, that enrichment stuff, you don't have to, remember? Okay, so the square root of x squared, what do you think the answer is going to be?
1.
Not 1, but x. Good. Yes, Jenna, good. All right, what about the next one? The sixth root of x to the 6th. Yep. Because if you write this in radical form, remember this is radical form, but if you write it in rational form, let me just show you. What you get is x. I don't have my 6 divided by 6. And what's 6 divided by 6? 1. So that's why you get just x. Does that make sense? All right. What about C? What's the 11th root of y to the 11th? Yeah, I got a bunch of y's. Good. What about the last one? The 4th root of r to the 8th. Okay, got an answer from Jenna, an answer from Sam. R, okay. R squared. All right, yes, good. Because what you would do, again, think about it, you could do R, and the 8 goes on top. Again, my terrible writing. The 4 goes on the bottom. So I can simplify that radical exponent to 2. Make sense? Okay. No, we didn't do this. Sorry, guys. I don't think we did any of this. Again, if we did, it was just Jenna or who's ever doing the extra credit. Composition, we did not do composition, and I'm pretty sure I thought I got rid of this. All right, so that's it. That is it. Anybody have any questions? We're done. Okay. John, I saw your note the other day. I hope you're feeling well. Anybody else? You guys sitting here? Anybody over there? Questions? If you have no questions, remember all of you guys you all participated. Go under webinar and discussion, type in attended, you're good to go. And I will write my question whenever I get there. Alrighty? All right, guys. Have a great day. Yay.